Okay, Emma, say hello. Now show Daddy where the moon is. There it is. Correct. Wow. Now, what shape is the moon? Yeah, we'll put that away in a minute. What shape is the moon? Is it a square?
No.
Is it a rectangle?
No.
Is it a pentagon?
No.
Is it a dodecahedron?
No.
Is it a circle?
No.
Is it a semicircle?
Yeah.
Well done. Well done. So I've just had a nice 3-week break at home and I spent that time with the family, and my young daughter just had her 2nd birthday a few days ago. As you can see, her shape recognition is coming along very nicely. Now, before getting into the video, I thought we'll have a bit of fun with perspective and trusting your senses, which are things that flat earthers are constantly telling us to do. Trust our senses and understand perspective. Here is my wife in a room. Considering perspective and trusting our senses, if my wife is 167 centimeters tall, try to figure out the approximate size of this room. And we'll come back to that at the end of this video. So we're going to have a look at equatorial mounts again briefly, because these are quite literally tangible proof that the Earth cannot be flat. The polar alignment and the single axis tracking of objects in the sky simply cannot work on a flat Earth. And we'll have another look at that. In addition, we're going to look at 2 of the coordinate systems that astronomers can use for determining the position of objects in the sky. Now, for some reason, flat earthers still struggle with understanding how these instruments work, and I have an email from a prominent flat earther who, in a moment of honesty, told me that he does not understand how the equatorial mount works and is quite embarrassed about it, and yet publicly on his channel he happily proclaims that it works fine on a flat Earth. Well, I can tell you once again that any flat earther who believes this instrument can work on a flat Earth does not understand how it actually works. So I'll play part of this video now, which is an excellent visual demonstration of how the equatorial mount works, and then we'll take a look at one of the claims flat earthers make, trying to justify or rationalize how this works on a flat Earth, and we'll show you why this claim is utterly ridiculous.
The Earth turns around in 23 hours 56 minutes and 4.0989 seconds. This is called a sidereal day. The mount has 4 axes. Azimuth is for keeping your mount parallel with Earth's rotation axis, and altitude for adjusting your latitude on Earth. So your telescope can be used no matter where you are, on the northern hemisphere and also the southern hemisphere. So if you are like me in the Netherlands, roughly on 52-degree latitude, you put the altitude at 52 degree, pointing to magnetic north. A program like Polar Finder shows the current position of Polaris. Now, using the polar scope, we can adjust for true northern celestial pole. Turn the right ascension so that the Polaris marking is on the correct place, and adjust altitude and azimuth to center Polaris in the circle. The declination axis is for pointing at the stars. Right ascension is for compensating Earth's rotation and pointing at stars. Now we point at an object in the sky. If we now start tracking at sidereal rate, the object stays centered in your telescope. This can be done for hours, until the object disappears on the horizon.
So a couple of days ago, I saw this comment by Vimal Ramachandran on Where's Wally's channel, and he stated, "I heard Bob of Globebusters saying in a recent show that the EQ mount tracks the sun with one axis of motion because the circle it traces in the sky is so large that the local path over our head is like a straight line." Now remember, Bob Nodell was busted lying about being a commercial pilot. And this is the web archive of his profile on the FEIC website, where it states he is a commercial, instrument and multi-engine licensed pilot. However, as we know, the FAA record confirms that he is only a private pilot, single engine. And when this was exposed, he quickly changed the profile. It now no longer states that he is a commercial pilot. It simply refers to his experience as a pilot. So as we know, if you catch a person telling just one lie, you really can't trust anything they say from that point forward. But anyway, let's look at this claim, because I've seen other flat earthers make it as well. And the claim is that the circle the sun traces in the sky is so large that the local path over our head is like a straight line. Now, this is complete nonsense. And the reason it is nonsense is because in the summer months, from Sydney, Australia, for example, on the 14th of December, we have 14 hours and 23 minutes of daylight. Now, on the flat earth model, the sun is moving in a 360-degree circle every 24 hours. So 12 hours would represent half of that circle. 14 hours of daylight means we can see the sun for more than half of this circle. So to make a claim that the local path over your head is like a straight line completely contradicts the flat earth model itself. 14 hours of daylight means we are seeing the sun move for more than half of this circle. So I'm sorry, Bob, and any other flat earther who actually believes this, but it just proves you still don't understand how the equatorial mount works. Now, I believe they're having another Flat Earth International Conference in about 6 days. So if you're paying good money to go to this conference, why don't you ask Bob why he lied about being a commercial pilot? Or perhaps ask the other speakers if they knew Bob was lying about it. Were they part of the deception? Or were they just being duped by Bob as well? I'm genuinely curious. I've asked this question myself on Bob's Globebusters channel, but my comments get deleted. So here is my P900 on a small equatorial mount, and any astronomer will tell you that when you put an equatorial mount in solar tracking rate, it will rotate 360 degrees in 24 hours. That is precisely 15 degrees per hour. So if we look at this position here, 12 hours later, the mount will have moved 180 degrees. That is precisely 15 degrees per hour. Now that doesn't change. It is the same rate from any location on Earth and any day of the year. 15 degrees per hour. The only thing that will change is the angle of the polar alignment, because that is based on your latitude, and also the angle of declination, and that will depend on the position of the sun north or south of the equator. Now, the geometry of the equatorial mount also explains why the days are shorter in winter months and why they are longer in the summer months, and it has to do with the declination angle. Now, at the moment, this camera has 0 declination, and that is what we would experience on the equinox. And that is where we have close to 12 hours of daylight. And as you can see, with the equatorial mount shaft running vertically, the camera is horizontal. And because we have 0 declination, when that mount rotates 180 degrees, in 12 hours, the camera is again horizontal. So it has moved from sunrise to sunset in 12 hours. Now this is the declination angle, and this is what changes as the sun moves north and south of the equator for 6 months of the year. Now in the June solstice from the southern hemisphere, we're going to see 23.4 degrees of declination. So approximately like that. Now you can see when the equatorial mount shaft is vertical, the camera is actually pointing below horizontal. So the equatorial mount has to actually move a little further before that camera lens is horizontal. And now if we continue to rotate at 15 degrees per hour, you can see that the camera will again become horizontal before the shaft is vertical. So that means we're going to see a sunrise and a sunset in less than 12 hours. Now during the December solstice, we're going to see declination in the opposite direction. And there you can see with the equatorial mount shaft vertical, the camera is pointing upwards. So to have that camera horizontal, we need to go earlier in the day. And now, as the equatorial mount moves 15 degrees per hour, it needs to move past the vertical to have that camera once again horizontal. So the equatorial mount had to move more than 180 degrees to get the camera from horizontal to horizontal, sunrise to sunset. But the key point here is that the mount is always moving at 15 degrees per hour. No matter where you are on Earth, no matter what your polar alignment angle, or no matter what the declination angle of the sun, it will always require 15 degrees per hour of movement on this mount to track the sun. Now this motion of the sun, measured at 15 degrees per hour from any location on the Earth, is an irrefutable fact, and we can see that using an equatorial mount. Recently, I noticed a flat earther was using the wrong coordinate system to try to determine the angular rate of movement of the sun. Now here we see in Sky Safari Pro 6 the equatorial coordinate system, and that has the poles at the south celestial pole and the north celestial pole. So everything is rotating in accordance with the direct rotation of the Earth. Now we can also use the horizon coordinate system. And the horizon coordinate system gives us an azimuth and an altitude based on the observer's location. So it is based on your position on the Earth, and therefore somebody at a different position is going to have a completely different grid to what you're seeing. Now using this horizon coordinate system is absolutely pointless when it comes to determining the angular rate of movement of the sun, because it does not reflect accurately the angular change in position from hour to hour. It is a horizon coordinate system, and as you can see, the spacing between the degrees of azimuth reduces as we get closer to the zenith. And that means we're not going to have a linear rate of change as the sun moves across the sky. So it is completely pointless trying to use this coordinate system to determine the angular rate of movement of the sun. Now this part might get a little confusing for flat earthers who struggle with geometry in 3 dimensions, but the purpose of this demonstration is to show that the rate of change of azimuth of the mount is not linear as an object crosses the meridian close to the zenith. Currently I have the mount set up in alt azimuth mode, pointing north, and it's linked to the iPad and this planetarium program. What I'm now going to do is select an object close to the zenith and close to the meridian. And when the mount tracks to that position and then follows it across the meridian, you'll see just how fast that rate of change increases. So let's pick that point here. Let's now go to that location, and remember the mount is in alt-azimuth mode, so it is changing 2 axes. So we now just have to wait a few minutes until that star crosses the meridian, and you'll see just how fast the mount has to move in this mode to keep up. If we had the mount in equatorial mode, it would simply have to rotate 1 axis at a constant rate. In alt-azimuth mode, it has to move the azimuth at a much faster rate as it crosses the meridian. Now I can hear that already starting to speed up. And now you can literally see it moving. And remember, if this mount was in equatorial mode, it would be moving at a steady 15 degrees per hour to track that star. You can see just how fast that azimuth angle is changing. And once the object moves past the meridian, the azimuth rate is going to reduce. So it is not linear in this mode. And when we're measuring the coordinates using the horizon coordinate system, they are not going to show a linear rate of movement. That is why it is completely wrong to use that coordinate system to try to determine the angular rate of motion of the sun. I don't know if you can hear it in the video, but I can hear the motors in that mount slowing down now as that object moves past the meridian. And as you can see, the mount has changed a significant number of degrees of azimuth in just a few minutes. Certainly a lot more than 15 degrees per hour. If the mount was configured in equatorial mode, that would have required motion on 1 axis only at 15 degrees per hour. You must use the correct coordinate system to determine the angular rate of motion of the sun. So the moral of the story here is that you cannot use the horizontal coordinate system with elevation changes or azimuth angle changes over 1 hour to accurately measure the angular rate of movement of the sun. It just doesn't work that way. It's like trying to plug a UK power plug into an Australian power outlet. It simply won't work. It just doesn't work. So how did you go with the dimensions of the room? Let's play the full clip. Perspective. Trust your senses. Okay.
Где луна-то?
Да.
Она квадратная?
No.
Она круглая?
No.
Она прямоугольная?
No.
Она треугольная?
No.
Она полукруглая?
Да.
Молодец, умница.
Well done.